Hello again, Math 10Cs. In today's lesson, we're going to finish looking at solving systems of linear equations algebraically using the elimination method, albeit this time we're going to look at some progressively more difficult equations to solve. All right, so just two examples to look at. So let's start with the example number 5. So solve the following system using elimination. So we have 4x plus 2y minus 13 equals 0. So we're going to call that equation number 1. And we have 3x is equal to 5y plus 26. Now, the problem with these two equations is they're not written in the correct format to do elimination. So this is the first thing you want to do. So I'm going to say to carry out elimination, must write equations in the form. You want the variables on the same side, so we want to have ax plus by, and you want the constant on the other side. Okay, so right now, neither of these equations are in that form, okay? So we're going to have to do a quick little modification just to get them there. Now, I'll do the work up here just because we don't have a whole lot of space to write with. So let's do the first equation to begin with. So 4x plus 2y minus 13 is equal to 0. This one's easy to get in that format because right now the equation's written in general form. All I want to do is move the constant term over to the other side. So I'll just add 13 and add 13. And then I would have 4x plus 2y is equal to 13. Let's box that equation and call it equation number 3. Okay, next equation. We have 3x is equal to 5y plus 26. So the issue with this equation is the y is on the wrong side because I want the variables terms to be on the same side of the equation. So I'm going to subtract 5y, and then I would have 3x minus 5y is equal to 26. Okay, we're going to call that equation number 4. Now that I have these two equations written in the correct format, I can stack them correctly to do the elimination. So let's stack the two equations. So we have 4x plus 2y is equal to 13. And we have 3x minus 5y is equal to 26. Now, in order to eliminate, I need to have the coefficients with the same numerical values. So none of them do. The x coefficients don't have the same values. The y coefficients don't have the same values. So then I would identify, can I multiply one of the equations by a number so we can get the same coefficients? No, because there's no way to multiply a whole number by 3 to get a 4. And there's no way to multiply a 2 by a whole number to get a 5. So we have to use the little LCM trick to do this. Okay, I'm going to eliminate, let's eliminate y, okay? So you could eliminate x, but let's try to eliminate the y term. Okay, so we have coefficients are 2 and 5. So my LCM for y terms is going to be, what's the lowest common multiple between 2 and 5? It's 10. So now we want to multiply both these equations by something that is going to make it so you have 10y and 10y. Okay, first equation. What do you need to multiply the entire equation by to get 10y there? So what times 2y would be 10y? You're going to multiply by 5. And then this equation, what do you need to multiply by to get 10? Well, what times negative 5 would be, don't worry about the negative, okay? What times 5 would be 10? It's going to be 2. So then, if you write these equations out, it would be 20x plus 10y is equal to 5 times 13 would be, let's check here, 5 times 13, 65. Okay, second equation, 2 times 3x would be 6x. 2 times negative 5y would be negative 10y. And then 2 times 26 would be 52. Okay, now, what do you do to get rid of the y's? Add or subtract? Add them because the coefficients are opposite integers. Okay, so this would turn into 20 and x and 6x would be 26x plus 0 is equal to 65 and 52, I think is going to be 107. Well, let's just double check that. 65, 52, 117, my bad. Okay, 117. Okay, and then let's rewrite this up here. So I'd have 26x is equal to 117. Okay, we need to divide both sides of the equation by 26. Divide 26, divide 26, that would cancel off. Okay, then we're going to get x is 117 over 26. Okay, this is pretty ugly in terms of a fraction, and it's actually not easy to see, I think, what number divides unevenly. We can divide both the top and the bottom by 13. This will reduce it. Okay, divide 13, and then 117 divided by 13 is 9. And then 26 divided by 13 is 2. Okay, so my x coordinate is going to be 9 over 2. Now, to get the y coordinate, we just plug it into the other equation. I shouldn't say into the other equation. You can plug it into either of the original equations. I'm actually going to plug it into equation number 3, okay? Just because the original equations are not really in a great format to like solve for the variable. Actually, you know what? Equation 2 is not bad. Let's sub it into equation 2. Okay, so I'll say sub x equals 9 over 2 into equation 2 to solve for y. Okay, so the equation is 3x is equal to 5y plus 26. So we're going to replace x here with 9 over 2. Okay, so this would give you 3 times 9 over 2 is equal to 5y plus 26. Okay, this fraction unfortunately doesn't reduce, so it would just become 27 over 2 is equal to 5y plus 26. Now, unfortunately, we can't get rid of it. I mean, unfortunately, this fraction doesn't divide evenly, so we need to get rid of it. So the way I'm going to get rid of that fraction is I'm going to take the entire equation and I'm going to multiply by that denominator. So I'm going to multiply the whole equation by 2 to get rid of that. Okay, so then this would turn it into, okay, 2 over 2 would cancel. So that would just leave you with 27. 2 times 5y would be 10y. Sorry, the 2 here and the 2 down there cancel, but otherwise the 2 does need to be applied to every single term. So this would be 2 times 5y is 10y, and then 2 times 26 would be plus 52. Okay, now to solve for y. So we're going to minus 52, minus 52. So that's going to give me 27 minus 52 is negative 25. And this would be equal to 10y. And then I need to get y by itself, so I'm going to divide by 10, divide by 10. The 10s cancel. And then we're going to get a fraction again, but this fraction is easier to reduce at least. So this would be y is equal to negative 25 over 10. And if you divide the top and the bottom by 5, you get y is equal to negative 5 over 2. Okay, so the solution to this system is these lines would intersect at a point with coordinates of x is 9 over 2 and y is negative 5 over 2. Okay, next one. This one's actually really unpleasant. Okay, so we've got equation 1 and we've got equation 2. Okay, the big problem with this equation is, first of all, we have fractions. Okay, that's bad. And the other issue is you've also got brackets as well. And it's not really in the correct format yet either. So it also needs to be in the format ax plus by is equal to c. Okay, first things first, the fractions are the worst thing to deal with. So let's eliminate them first. So what I want to do is, so for this first equation, what do you need to multiply by to get rid of these two fractions? Now, if you have two fractions and two separate denominators, you actually need to look at the lowest common multiple of the two denominators, okay? So what I'm going to do here is identify the lowest common multiple of 3 and 5, which is 15, and I'm going to multiply this entire equation by that. Okay, let's start off with this, and we'll deal with equation 2 in a second. Okay, so this 15 has to go to everything. So I'm going to write it out as 15 multiplied by x minus 2 over 3 minus, so again, this 15 has to go here. It has to go there. It has to go over here. So then 15, and then y plus 2 over 5 is equal to, and 15 times 2 would be 30. Okay, now I can simplify a little bit. So, okay, 15 divided by 3 would be 5. 15 divided by 5 would be 3. And then we're going to use the distributive property. Okay, so actually I can rewrite it out just so it's not looking so cluttered. So this would be 5 x minus 2 minus 3 y plus 2 is equal to 30. Okay, now we use the distributive property. So the 5 goes to this and to this. The negative 3 goes to this and to this. So this would then be 5x minus 10 minus 3y. And the negative 3 times 2 would be negative 6, which is equal to 30. Okay, let's collect these two like terms. So this would then be 5x minus 3y minus 16 is equal to 30. And remember, we want the constant terms on a separate side from the variables. So we're going to add 16. We're going to add 16. And then I'm going to get an equation that I can now start with. Okay, so that equation is 5x minus 3y is going to be equal to positive 46. Okay, we're going to call this equation number 3. Now let's deal with the second equation. So we've got fractions in this one. So we have a 5, and a 2. So once again, you need to identify the lowest common multiple between all of the fractions. Okay, so the lowest common multiple between 5, 5, and 2 would be 10. So we're going to multiply the entire equation by 10 just to get rid of the fraction. So this is going to turn into 10, and then 3 over 5, x plus 1, and then minus 10, and then we have 4 over 5, y minus 3 would be equal to 10 times 21 over 2. Okay, let's start to reduce these fractions now. Okay, 10 over 5 is 2. Negative 10 over 5 is also 2. And then 10 over 2 would be 5. Okay, so let's rewrite this out. This would then be, we'd have a 2, and then 3, x plus 1, minus 2, and then 4, y minus 3. And then this would be 5 times 21. Okay, in terms of the order of operations, if we're using distributive property, I'm going to combine this 2 and this 3, and this negative 2 and this 4 through multiplication. So this would be 6, and then x plus 1, minus 8, y minus 3 is equal to 5 times 21 would be 105. Okay, now I can use the distributive property. So this 6 has to go to the x and the 1. This negative 8 has to go to the y and the negative 3. And then this would be 6x plus 6 minus 8y plus 24 is equal to 105. Okay, let's collect the like terms. So this would be 6x minus 8y. And then 6 and 24 are combined to give you 30 is 105. But again, if I'm going to stack the equations correctly, I need the constant term to be on the other side. So I'm going to subtract 30, and then you get 6x minus 8y is equal to, this will be 75. Okay, we're going to box that and call it equation number 4. Okay, now I'm going to stack the two equations, and we're going to solve, well, let's stack them to begin with. Okay, so let's do it over here. So we have 5x minus 3y is equal to 46. And then we have 6x minus 8y is equal to 75. Now, unfortunately, again, you can't add or subtract them right away because the coefficients for each variable are different. And nor can you multiply one of the equations by a number to make this work, okay? Because you can't go from 5 to 6 with the whole number. You can't go from 3 to 8 with the whole number. So, got to do the LCM trick. Okay, this time around, I think I'm going to try to eliminate, let's eliminate the x, okay? So to eliminate the x, we need to identify what the lowest common multiple between 5 and 6 is. So the lowest common multiple between 5 and 6 would be 30. So LCM is 30 for x terms. Okay, so what do you multiply each equation by to make the x term 30? Multiply this one by 6 and this one by 5. Okay, so this would turn the first equation into 30x minus 18y is equal to 276. And the second equation would be 30x minus 40y would be 375. Now we want to eliminate x, so I'm going to subtract 30. Okay, so subtracting 30 would give you 0 here. Negative 18 minus negative 40 would be negative 18 plus positive 40. So that's going to be positive 22y. And then 276 subtract 375 would be negative 99. Okay, so now we have 22y is negative 99. And then I want to isolate for y, so I'm going to divide both sides of the equation by 22. Divide 22. Divide 22. The 22's cancel. And then you'd have y would be equal to negative 99 over 22. And then the top and the bottom both divide by 11, so then I get y is equal to negative 9 over 2. Now to solve for x, you need to plug this into like one of the original equations, but there's no way I'm plugging y into the original equation and solving for x. It's too much of a mess, okay? I'm just going to plug it into one of the condensed equations that I have, okay? So I'm going to sub y is equal to negative 9 over 2 into, let's put it into equation 3. Okay, so equation 3 is 5x minus 3y is equal to 46. Again, it would just be way too much of a mess to take y equals negative 9 over 2 and plug it into like the original guy. It's just too much stuff going on. So plug it into our simplified equation. Okay, so we're going to replace y with negative 9 over 2. And this will actually, it's not going to be great in terms of how it simplifies, but it's not bad. Okay, so you'd have 5x minus 3 times negative 9 over 2 would be equal to 46. So you'd have 5x
Ian
plus
Shaw, please come to student services. Ian Shaw, please come
27 over 2 is 46. We need to get rid of that fraction. Okay, we don't want that. So we're going to multiply the entire equation by 2. 2 has to go here, here, and here. And then this would give us 10x plus 2 times 27 over 2 is equal to 2 times that would be 92. Okay, the 2's here cancel. So now I'm just down to solving for, so I'm like really running out of space. Okay, 10x plus 27 is 92. So to solve for this, we're going to subtract 27 from both sides, subtract 27. And then this would give me 10x is equal to 65. Divide by 10. So divide 10, divide 10. And then this would give you x is 65 over 10. Reduce the fraction by dividing by 5. Dividing by 5. And then I'd finally get x is equal to, this would be 13 over 2. Okay, so that's it for this lesson. In addition to the questions I assigned yesterday, you can also complete numbers 5 through 9.
Mr. Green's physical education class is in house today in room 233.
Okay, so starting on page 637, do numbers 5 through 9. Do numbers 5 through 9, A and C, and no need to verify in any of them. Okay, then I'll talk to you in the next lesson when we deal with applying this knowledge to word problems.